All right, back to 19. I actually had to fix it. I left a lot of it the same, but it needed to be different. The form you're going to be taught is either going to be a times the cubic root of x minus h plus k, or what I will probably demonstrate, because I told you I like exponents, is the 1/3 power. I know exponents bother kids, so I'm trying to push you towards it. I'm trying to get you to understand exponents. But h and k come from what you call, at least I call, the center of the graph. Now, why did I know this was a cubic root function? Is a very good point, because I know mother functions, and I know that that is what x to the 1/3 power looks like. That's what she looks like. This is a child of that mother. Another point that exists on the graph, before I get to that, 6,5 gives you the h and k in these forms. Okay? Another point that exists appears to be right here, and it is 5, 3. I've done enough of these already that I actually know what a is without doing the math. Maybe you get there too. And let's see, there's another point, even though you don't need it, which should be at 7, 7. If I'm thinking right, and it is. It's there. All right, let's talk about this thing. I'm going to plug in my h and my k, so I'd have x minus 6 to the 1/3 power, and then plus k, which is 5. Now, to figure out what a is, I'm going to take this other point right there. And everywhere I see x, I'm a 5, and everywhere I see y, I'm a 3. So 3 is a times 5 minus 6 to the 1/3 plus a 5. And I'm writing that off to the right a little farther than usual because you need to figure out what this is. What is that? Now, I know it's -1, but you may not. So here it is typed in T84, 5 minus 6 rooftop to the 1/3 power. I know it's actually the cubic root of -1, so it's -1. So 3 is a times a -1, and then add 5. We're going to counteract addition of 5 through subtraction. So 2 is -a, which means my a value is 2. And this is y equals twice now x minus 6 rooftop to the 1/3 plus 5. Now, I want you to notice something here. I want you to notice the initial rise. The initial rise is, if you look at the grid, 2 units, and the run is 1. It's a real quick way of getting A. It's a real quick way. If you catch it, you catch it. If you don't, you don't. Number 20, write an equation for this given graph. And again, I'm going to teach you some other functions. This thing looks a lot like this bad boy. And this bad boy is y equals x cubed. All right? This has to be a transformation of y equals x cubed. So your form is a times x minus h cubed plus k. Some of y'all were struggling with absolute value of x minus h plus k. More of you were struggling with quadratic a times x minus h squared plus k. It's the same form. That's why I preached understanding it in the beginning. Here's my center. It's at -2, -3. And here's another point. So it gives me an x and a y for later. So I'm going to plug in my center first. If I take away a -2, I'm +2, down 3. Then I'm going to plug in 0, 5. Y is 5 and x is 0. And I'm going to figure out what this is. Okay, if I don't know what 0 plus 2 is, God help me. If I don't know what 0 plus 2 cubed is, God help me a little more. But, on test day, you're not supposed to worry about that. It's 8. So 5 is 8a minus a 3. Did I not make this thing funny? It was supposed to have fractions. Whatever. I get an 8. 8 is 8a, so a is 1. So y is ununderstood 1 times x plus 2 cubed, and then minus a 3. That blasted thing was supposed to have fractions. Didn't. See if I did the square root function right or not. This is an upside down arm. So again, your form is y is a times the square root of x minus h plus a k, or y is a times x minus h to the 1/2 plus a k. You do you, okay? Understand they're equivalent. Arms don't have centers. They have a starting point. This is where you get h and k from. That's where they start. There is some unseen symmetry. I don't know if you kind of see what I'm doing with my pencil. If you cared about the negative square root, you would draw above, but you don't. Things that I do know, this thing is opening down, so the a value will be negative. No matter what, the a value will be negative. But let's start plotting points and plugging in. This is at -2, -3. And I need another point, and I'm very confident that this is a good one. You can actually use that one, which is what bugs me. I think we can get a -1 back. But we're going to go ahead and use this one. This is at 2, -5. You just need another point. So let's start our plug-in stuff. Let's use the radical notation for this one just so you guys see radicals and exponents. A value is unknown. Square root of x minus a -2, that becomes +2, and then -3. And now I need a, so I plug in my x's and my y's. My x's and my y, whatever I said. -5 is a times the root of 2 plus a 2 minus a 5. 2 plus 2 is 4. The square root of 4 is 2. So 2a minus 5. Phooey. What happened here? You see my little dilemma here? I have a heck of a dilemma here. I do have an issue here. Why'd I get a 0? There's a problem. Isn't there? I don't think I did anything wrong. Plus 2 is 4, 2a. Oh, well, there's the problem. Why did I make that a -5? Easy to fix. I'm not flawless either. Go back and fix that. If I add a -3 to -5, I get a -2. So -2 is 2a. A value is -1. Hopefully you caught that mistake quicker than I did. So here's my equation. It is y is negative square roots of x plus 2 minus 3. Or I could very well write this as negative x plus 2 to the 1/2 minus the 3. Just whatever I feel like doing. 22, some simplification. Simplify the 9th root of x to the 7th over the 5th root of x. So what I would recommend is that you use your p over r notation. X to the p over r is the rth root of x to the p. So when I look up top, my root is 9 and my power is 7. I could rewrite this as x to the 7/9. Okay? When I look down low, I have the understood 1, so this is x to the 1/5. Now what's coming across my brain is x to the a over x to the b, which is x to the a minus a b. Now I happen to know that 7/9 is bigger than a 5th. So this guy becomes x to the 7/9 minus a 5th. And if you don't know what 7/9 minus a 5th is, big freaking whoop, right? You just push them buttons. 7/9 minus 1/5, math enta, should be 26/45. Wait a second. Yeah, this is different. I actually changed these problems. I did these at like 5 in the morning, so I didn't write similar. I just changed them for some reason. I think I got in the habit of doing that on the graphs. The number I got from the TI-84 was 26/45. And then you go back and you look at this notation. Okay? This was given as a radical. It will be answered as a radical. This is the 45th root of x to the 26th power. All right, 23, some simplification. If a number is even, a good thing to do is divide it by 2. It is. It's a very good thing to do. So I'm going to focus on this 5th root of 2048 for just a minute. And the 5th root of 2048 is even. I'm going to think of that as 1024 times a 2. Now remember, you can break these apart. That's 1024 to the 1/5 times 2 to the 1/5. One of those is ideally evaluatable. One of them is not. If my brain was working this right this morning before the sun came up, that's a 4. Good. So I end up with 4 times the 5th root of 2. That's what happens to the number, okay? There's a 6 out there. A 4 gets introduced, 6 times 4. I'm going to leave just a little bit of space. What's inside is definitely a 2. 5 enters 9 one time with a remainder of 4. Now 6 times 4 is 24. 24z, 5th roots of z to the 4th power. And what you can see now is that like terms have been created. Because they have. And all I got to do is focus on that. 24 minus 2. I would have a 22z times the 5th root of 2z to the 4th. And I do want to talk about something else I explained to you guys earlier. 24, oh, sorry, I can't do that anymore. 4 to the 5th is 1024, times the 2, which for some reason I threw out the window, times the 2 is 2048. So there's another mistake Milbrath made. I accidentally threw away a 2. Sorry about that. Didn't mean to. All right. Final answer is right, though. I know that. 24 is use a table. These won't be. Oh, there's only 2 classes I actually got to talk about the table with, so this might be a little bit new to y'all. Some of you, anyways. F of g of -2. And again, remember, you think about this as f of g of -2, written like that. So I get to use the table to figure out what g of -2 is. So I go to -2, I go to where x is -2, and I look at function g. It's -3. Becomes f of a -3. So now I go to where the table is -3, and I'm looking at function f, and it's 11. Final answer. B is golf, and again, remember that's g of f of 3. So the first thing I do is I kind of figure out what f of 3 is. I go to where x is 3, and I look at function f. I get a -1. And I do replacement, g of a -1. So I go to -1, I look down at g, and I get a 0. Gog of 2, g of 2. So I go to 2, I look at g, and I know that g of 2 is a -3. So this now becomes g of -3, and it spits back a -8. Those are going to be rough for some kids. I remember thinking when I saw those the first time when I was your age, I don't know why, but it mentally drained me. Now it doesn't. I think it was just I like to do things up here. A lot of y'all do that. And it kind of drained me. So now I don't do things up there. I write as much as possible, and suddenly I can do everything. All right, we'll use the graph, something I never talked about in class. Use the graph to answer the following. You're told that this is the top one, g of x, and here's the bottom one, f of x. All right, you're supposed to find golf of 6. So So what you really care about first is figuring out what f of 6 is. Right? Because it's g parentheses f parentheses 6. So this is function f. I go to where x is 6 and the y value is 2. It's a 2. I use substitution, and the actual goal was to figure out what g sub 2 is. So now I go to function g and I go to where x is 2. It's right here. Turns out it spits back a 2. Final answer, number 2. Last one that I'm going to do, and I'll be done with the video for the similar twin, is fog of -1, or f of g of -1. And my first task is to figure out g sub -1. So again, here's function g. When x is -1, the y value is 3. And that output becomes input. Replacement is done. New goal, f of 3. I go to function f. I scan along. Phooey. There is no f of 3, is there? So bad example. So let me make something else up. Sorry about that. Still going to do fog. Let's do fog of 6. Start over. That's f of g of 6. So I glance at my graph, I look at function g, and I see where x is 6, and it says the y value, or the output, is 5. And that goes there. So now I go to function f, and I go to where the x value is 5, and the return value, the output, is a 1. All right, there you go. There is your similar twin to help you work on the twin, which is similar to your test. That took a lot of my time, boys and girls. Quit being angry at me. Be angry at yourself. Do the work I do.